that'll be a small area that can be done in a day, rather than the whole glacier, which would take weeks or a whole month. By the way, the size of the arc on this scale I have up here. That's the biblical size of the arc. And so that's what we will be looking at within the hole. And so maybe it would be like from here to there, if that was the image. So anyway, this is just 3 weeks old. Just letting you know there's something there. We should examine it. And we may not find any remnant of an arc up there. But it's worth looking. We got the tools. All we need is now Turkish permission to get up there on the mountain and do it. And that's been lacking for about 15 years due to the Kurdish rebellion up there. Just from a scientific point of view, a bowl of ice, very stable, they could do an ice core through there for climate analysis. And so when I get around to it, I'll suggest that to scientists over in Building 810 of the Denver Federal Center. That's where the National Ice Core Laboratory is, and they have cores from Antarctica and Greenland, and I've talked to the people over there before, and I know that there are people at other universities that are interested in drilling mountaintop glaciers just for climate analysis before those glaciers disappear. So anyway, even from a secular point of view, it's worthwhile going up there and drilling a hole in that location. Before I have discovered those vents, nobody knew where the vents were. So this is all brand new information. Here's another idea. And carbon-14, we had this discussion, and some people were trying to do carbon-14 dating of dinosaur bones. And John Baumgartner, who's spoken to us a couple of times, suggested that it would be more valuable to get a hold of some fossil animal from the Ice Age times to detect a rise, a rapid rise in the background carbon-14. And say if some part of the animal was old, another part young, there could be a tremendous apparent age difference across those body parts. Well, I suggested examining the tusks of mammoth and mastodons. Now, the growth rate of modern elephants suggests that a 2-meter long tusk, that's 2 meters, like that, would have an age span of 11.8 years, according to the published growth rates, give or take a little bit. So if the tip of a mammoth tusk is greatly older in radiocarbon years than its base, then the exponential rise in carbon-14 after the flood can be documented. And for comparison, of course, scientists like comparisons. The same tip to base age span can be done for modern elephant tusks, and that should show nothing unusual from expected growth rates. Okay, so I've been running equations on this. We haven't done this yet. We're still just trying to see, is this going to work? Well, Michael Ord's assessment of the Ice Age indicates it's starting a couple of centuries after the flood caused by the hot oceans and lasting for perhaps 500 years. So that's what we're working with, give or take some error. And during that time, the carbon-14 to 12 ratio should have been increasing rapidly and would have been recorded in the tusks. So we get a hold of one of these tusks, measure the, well, maybe 3 places, the tip, the middle, and the base, as to get a good consistent set of data points. So that's the idea, and see if we can detect something unusual there that's more than the expected growth rate age. Well, one of the theories for carbon-14 in the environment is that before the flood, there was very little carbon-14 in the environment, as shown by this little horizontal line down there. And then after the flood, things increased rapidly to present conditions. So we don't know what the actual rate of rise is, and so I just said, well, the rise halfway might be 500,000, 1,500, 2,000 years, and that gives different curves like that to go halfway to present conditions. Yeah?
I'm sorry, why would the carbon-14 ratio increase after the flood?
Okay, the idea there is that before the flood, there is tremendous carbon in the environment and the surface due to the plants and animals, and all of that is now buried. It's taken out of circulation. Now, the production rate of carbon-14 is something that is coming into the upper atmosphere. And so before the flood, we have maybe the same amount of carbon-14 being produced, but it's being diluted tremendously by the biosphere, which is now buried. The coal, the petroleum, even the carbonate rocks, all are created during flood times. And that took carbon-12 out of the system.
What are you plotting here? The amount of carbon-14 in the atmosphere or the amount of carbon-14 in post-flood ends?
Well, both. This would be the baseline rise of carbon-14 in the environment, which is then captured by the plants and animals. And so let's just say that an animal lived right here, and the carbon-14 is captured, and then the decay rate would just bring it down exponentially according to the normal decay law. Well, running through these equations, I said that a 2-meter tusk, the span in age in years, normally we'd expect about 12 years for a 2-meter tusk. And I run through the equations. Well, let's start here at 12 years. We get a tremendous age difference, tip to base, right here after the ice age, or right after the flood, and then decaying through the ice age. If the ice age is 500 years or 1,000 years, we're still up there pretty high, above 100 years apparent age difference from the tip to the base, where only 12 years would be the expected thing from the growth rate. So this is all theoretical right now, trying to use different equations and scenarios. It seems to be fairly uniform right here, even though I had 4 different scenarios for the rate of rise. They came out similar numbers. John Baumgartner questioned that this week, and I've looked at the equations. They seem to hold up all right. Okay, error analysis. I'm using a potential of